I'm now going to run through a couple of examples of product rule problems. You'll see I've got a couple products here that I'm taking a derivative of. The product rule, very, very straightforward. If you have some function of x, let's call it a u, times some function v, and you want to take the derivative of that, the product rule says very simply, you can take the derivative of the first term times the second, plus the first term times the derivative of the second. And you can continue that pattern for 3 terms. It just ends up being basically each time you're taking the derivative of one of the 3 terms, you're finding the sum of all 3 of those possibilities. I'm not going to do an example of that, but it's the same thing. So that's the basic pattern. And this works out really nicely. So I take the derivative of e to the 3x. Remember that e to a power is its own derivative. So it's e to the 3x, but I have to multiply by the derivative of the inside function. And I'm going to multiply by that out in front just so I can kind of simplify this here. So it's derivative of the first times the second plus the first times the derivative of the second. Outside function is sine. The derivative, of course, is going to be cosine of 6x. But remember, I have an inside function. Chain rule applies here, and so this is going to end up being multiplied by 6. Really a better form for this would be to take that 6 and move it out in front. So we get something that looks like this. You could factor out a 3, and you could factor out an e to the 3x. I'm not going to do it in this case. On the free response part of the AP exam, you really don't need to. Multiple choice wouldn't be the worst thing in the world, but I'm going to try to take a look at some factoring a little bit later. Okay, second example, same deal. Derivative of the first, power rule applies here, 4x cubed times the second. That's 3x plus 5 raised to the 6th power. Okay, for the second part, derivative of the first times the second plus the first times the derivative of the second part, okay? This is a 6th power function. Power rule says it'll be 6 times, I'll put the 6 out front, 3x plus 5 raised to the 5th power. Okay, so you multiply, this goes out in front, drop the power by 1. Remember to multiply by the derivative of the inside function, which in this case is going to be 3. Okay, chain rule, chain rule, chain rule. Can I simplify this? Sure. Okay, don't multiply through. The exponent's not applying to this coefficient out front. Let's see, in particular, this times 3 and times 6 is going to turn into an 18. So you can factor out a GCF, and there are actually several GCFs here. You need to look at numbers, you need to look at variables, you also need to look at those binomials and see if there's anything that factors out of both. Interestingly, there are actually only 2 terms here, okay? You've got this term here, you've got that second term there starting with the 18x to the 4th. And that's really all we're looking at here. So you basically look at those 2 terms and you ask what can be divided out? What's the highest power that can come out of both? Well, if you look at this, 2 divides out of both 4 and 18. Okay, so I'm going to have a 2 out here in front of parentheses. Come back, look at the variables. I can divide an x cubed out of both of these. Okay, and then finally, this looks a little strange, but the binomial can be factored out. I can divide a quantity 3x plus 5 out of both of these. Notice I can't take 6 3x plus 5s out because there are only 5 here, so I've got to take that lowest possible power. That's 3x plus 5 quantity to the 5th power. Okay? These things all got factored out. I've got a bunch of stuff then left in parentheses, so I've got to go back and see what I have. If I divide 2 out of that 4, I'm left with a 2. If I divide an x cubed out of the x cubed, I'm left with 1. Just not going to write anything down here. I've divided out 5 of the 3x plus 5s, so I have a 3x plus 5 left. Okay? Now for the second term, I have a plus here. Going back here, I divided out a 2. That leaves me with 9. I divided out 3 x's. That leaves me with 1. And then I divided out all of those 3x plus 5s. Okay? If you're doing this in multiple choice on the AP exam, they're going to go a step further. Notice there's some things that simplify here. I can multiply that out. That's 6x plus 5 plus 9x. Of course, 9x plus 6 is going to end up being 15x plus 5 times all this stuff out in front. So I've got the 2x cubed times 3x plus 5 to the 5th. And that's my final answer, okay? And again, you can check these things. Basically, this should multiply times all of these values to give you the original. So 2 times 2 gives you 4, x cubed times the 1 there gives you an x cubed, 3x to the plus 5 raised to the 5th power times this gives you 3x plus 5 to the 6th. 2 times 9 gives you 18, x cubed times 9 gives you x to the 4th, and then you get your 3x, quantity 3x plus 5 raised to the 5th power. But that's the type of thing that you're going to see in these problems. Okay? Let me take these down and run through a few more examples. Again, I think the more of these you see, the better off you're going to be. And definitely make sure you're trying these and just not watching me do it, because it's one thing to watch me do it, it's something very else, something very different to try to do these problems yourself. Okay, quantity 4x minus 2 cubed times the quantity 6x plus 1 raised to the 4th power. Again, derivative of the first, I have a cubic power function, so power rule. 3 times the coefficient gives me 3, inside function stays the same, raised to the 2nd power. Don't lose those exponents. It's something a lot of people had issues with on the last test. Derivative of the first times the second. So 6x plus 1 raised to the 4th power doesn't change. Plus the first, 4x minus 2 cubed, times the derivative of the second. Okay, that's a 4th power function. It's going to end up being a 6x plus 1 to the 3rd. 4 times 1 out in front gives me a coefficient of 4. And then remember, at the end, I need to multiply by the derivative of my inside function. So we can write this as something like 3 times 4x minus 2 quantity squared times the quantity 6x plus 1 raised to the 4th power plus quantity 4x minus 2 cubed. That's actually going to be 24. So plus 24 times quantity 4x minus 2 cubed times the quantity 6x plus 1 raised to the 3rd power. And again, depending on the situation, you may or may not need to factor it. If you need to factor it, you go back. 3 and 24, I can divide out a 3. Let's see, 4x squared, or 4x minus 2 quantity squared. I can take 2 of these out of both terms. So again, you're really taking out the lowest power. I can take out 3 quantity 6x plus 1s. So that's going to be to the 3rd power. And then I have everything that's left over. So I divided out a 3, that's gone. I divided out 2 of these, those are gone. I divided out 3 of these, I'm going to be left with 1 6x plus 1. Okay, then I have my plus. I divided 3 out of 24, leaves me with 8. 2 4x minus 2's, so I have a 4x minus 2 remaining, and then notice I took out 3 6x plus 1 quantities, binomials, and so it leaves me with this. Again, you can do a little simplifying. I've got 3 times the quantity 4x minus 2 quantity squared times the quantity 6x plus 1 quantity cubed. Inside parentheses here, that's going to be 6x plus 1 plus, it's going to be 32x minus 16. So 6 and 32 adds up to 38x. 1 and negative 16 add up to be minus 15. And by the way, one of the reasons that factoring can be useful if you're on a no calculator part of the AP exam, this is a derivative here. If I needed to find out where the derivative is 0 to find relative maximums or minimums, notice, whole thing's written as a product. So whatever makes this 0 would be a solution. Whatever makes that 0 would be a solution. Whatever makes that last term equal to 0 would also be a solution. So there are advantages to writing in factored form, even though you're not going to be required to in every situation. But you may come into a situation or two where that factoring is very important. So that's how a problem like that would work. Okay? Again, a lot of work, but if you notice, most of it's writing and copying and recopying. If you think about your individual derivatives, they're really relatively straightforward in the grand scheme of things. Okay? Continuing with this, let me do one final one. Let me find the derivative of quantity 3x plus 4 times the quantity sine cubed of 6x. Okay? In this example, I take the derivative of the first term. Notice derivative of the first term is just 3. Okay, so it's going to be 3 times the second term sine cubed of 6x, so far we're going along great, plus the first term, quantity 3x plus 4, times the derivative of the second term. And I can't stress this enough. Being organized, being careful, it's going to make a huge difference when you're doing these problems. Okay? I can't stress that enough. Okay? You need to take the derivative of sine cubed of 6x. There's a little bit more going on in that than we've really had in a lot of our other derivatives. Go off to the side. Go somewhere else. Find that derivative. Okay? Sine cubed of 6x. That's really the quantity sine of 6x cubed. Okay? So something is being cubed. U cubed, if you want to think about it like that. Power rule. That's going to be 3u to the second power times the derivative of the inside function. Well, inside function is sine of 6x. Heck, if you have to, go off to the side, find the derivative of sine of 6x. That's going to be a cosine of 6x times the derivative of the inside function. It'll be a 6 cosine 6x. Okay? This whole thing is the derivative of that. And of course, we can multiply that and get an 18. So I'm actually going to have an 18 sine of 6x quantity squared times cosine of 6x. So I'm going to put my 18 out here, and then I'm going to write down my sine of 6x quantity squared, and I'm going to multiply by my cosine of 6x, and there's my derivative. Okay? Again, can you simplify? Sure, you can divide out a greatest common factor of 3 and 18. In the grand scheme of things, that's really not going to make a huge difference. So again, if you're not on a multiple choice part of an AP exam, I would probably just leave it like that. But that's the idea. So again, can't stress it enough. Practice, practice, practice. You've got to do some practice with the product rule. And in particular, watch out for the chain rule, because the chain rule burns a lot of people when they're trying to do this. It's just very easy to forget that. So you get in the habit of going back and checking at the end after you've done a lot of practice. It really makes a huge difference.